In this lesson, we will discuss different ways to simplify trigonometric expressions. And so it's a good idea to have your note cards and your formula sheet in front of you as we go through these. For number one, as we start, a lot of times a helpful way to start these problems would be to change everything over into terms of sine and cosine. Now that's not going to be the best way for all problems, but it is a good way to start. So with secant, we know that is 1 over cosine theta minus sine theta times, and tangent is sine theta over cosine theta. And now we can go ahead and put sine over 1 and multiply. So we have 1 over cosine theta minus sine squared theta over cosine. And then we can put this together as a single fraction since we do have a common denominator. And 1 minus sine squared theta, that's going to be cosine squared theta. And again, that's coming from our Pythagorean identities over cosine theta. And then that will reduce down to just cosine theta. Okay, moving on to the next problem. Again, this one started very similar to the previous problem. I'm going to put everything in terms of sine and cosine. So tangent, I'm going to say times, and this is going to be sine of A over cosine of A. And then from here, notice that we can put cosine over 1 and do some canceling. And so all that's left is sine of A plus sine of A. And those are like terms, so we can add those. And we have 2 sine of A. Example 3 is a good example of a problem where you would not necessarily want to go to change everything over to sine and cosine. Here we have our Pythagorean identity that says cotangent squared u plus 1 equals cosecant squared u. So it looks like it might be a good idea to subtract cosecant u over to one side and move that 1 over to the other so that I would have cotangent squared minus cosecant squared. So when I do that with the identity here, notice I am going to generate exactly what we were given. So that tells me all of that is equal to -1. Okay, number 4. Again, another good idea for this one. You can change it all over to sine and cosine, and then you don't necessarily have to. It's up to you, whichever. Here, a lot of times we can separate out, since there's just a single term in the denominator, we can separate this and say that's really sine x over cosine x times tangent x plus cotangent. And then we can actually change sine over cosine to be tangent times tangent x plus cotangent. And we can use our distributive property here. And we can multiply this tangent x through to each part. And when we do that, we have tangent squared x plus, well, tangent times cotangent times that reciprocal is just 1. Our Pythagorean identity tells us tangent squared plus 1 is secant squared. All right, moving on to our next problem. Here with this one, again, you can put cosecant over 1, and you can do, you're adding your fractions, and remember we add fractions strangely. We do a cross multiplying, and so that's going to be cosecant squared theta minus 1 times cotangent squared is cotangent squared theta over the product of the denominators, which is going to be cosecant theta. Okay, now we go back and look at our Pythagorean identities. On the numerator, we know that cotangent squared theta plus 1 is equal to cosecant squared theta. And so if we do some rearranging, subtract cotangent squared over, notice we have 1 equals cosecant squared theta minus cotangent squared theta. And that's exactly what I have over here. So I'm going to replace all of this numerator with 1. So I have 1 over cosecant, and that's going to reduce down to just sine theta. Our next problem, this problem, it would be a good idea to decompose this fraction, and that just means we're going to separate this back out into the two fractions it was before it was put together. So we're going to have cosecant beta over cosecant beta minus sine beta over cosecant beta. So this first here is going to be 1 minus, now keep in mind that's really sine beta over 1 over sine beta. And so that side will simplify to be 1 minus sine squared beta. And 1 minus sine squared, that is part of our identity, and we know that's going to change over to be cosine squared beta. Okay, this next problem, we would need to put this together as one single fraction. And so in order to do that, again, we would cross multiply here. We have secant u times cosine u minus sine squared u, and that is all over sine u times cosine u. Now, secant times cosine, since secant is the reciprocal of cosine, when I multiply those, I get 1, and then minus sine squared u over sine u cosine u. In the numerator, 1 minus sine squared, that's going to give us cosine squared from our Pythagorean identity over sine of u times cosine u. And those cosine, that's going to cancel. And so I'm left with cosine over sine, which is cotangent u. Number 8. Now this time we're not able to decompose that fraction because it's not just a single term in the denominator. And so this problem, it looks like it might be the best thing to do is go to sine and cosine, simply because that's about the only thing these would have in common. So I'm going to change tangent. That's going to be sine alpha over cosine alpha. And that's all over, secant is 1 over cosine alpha, and just minus cosine alpha, and I'm going to put that over 1 so we can get a common denominator. So I'm just going to bring over the numerator. We're not ready to incorporate that so much yet. But in the denominator, again, we can do our cross multiplying, so we're going to have 1 minus cosine squared theta, or alpha, all over cosine times 1, so cosine alpha. And we can do some changing out with our trig function here because this portion, that's going to be sine squared. So I'm going to bring over the numerator over cosine alpha. All of that is over sine squared alpha over cosine alpha. Okay, so if we go through our simplifying here, do keep in mind that this is a complex fraction. You have the numerator, and then we're going to multiply by the reciprocal. So we're going to multiply by cosine over sine squared. So we have quite a bit of things here to cancel out, and one of those signs is going to cancel up here. So really I have 1 over sine alpha left, which is secant alpha. For our next problem, here, your problems that look like this, a lot of times the distributive property is going to be, or FOIL, is going to be your best route here. So if we do our FOILing, we're going to have cosecant squared x minus cosecant x. So that's going to multiply out here. And then on the inside, we're going to have positive cosecant x and then minus 1. And this is all going to be over cosecant squared x. Now we can cancel these since those are like terms with different signs. So we have cosecant squared x minus 1 over cosecant squared x. And for this one, we can simplify it a couple of different ways. One way, a lot of times people want to decompose this fraction into cosecant squared x over cosecant squared x minus 1 over cosecant squared x. You certainly can do that, and that's going to give us 1 minus sine squared. And again, 1 minus sine squared x is cosine squared x. Okay, for number 10, since most of this is already in terms of sine and cosine, let's go ahead and just rewrite tangent to be sine of theta over cosine of theta. And then we're going to add that over here, and we will go through and add these fractions together by doing our cross multiplying stuff. So we're going to multiply here to here, so that is sine theta, and you need to put that other part in parentheses simply because you're going to be multiplying each term, plus, and multiply up here, you're going to have cosine squared theta over the product of the denominators, and I'm not going to multiply out those denominators. I'm just going to rewrite it like this in hopes that something will cancel. The numerator, we are going to have to do our distributive property. So here we're going to have sine plus sine squared theta. So sine theta plus sine squared theta plus cosine squared theta. And that's going to be over cosine theta times 1 plus sine theta. In our numerator, we have this identity sitting here, and so I know that's all going to be 1, so we're going to have sine theta plus 1 over cosine theta times 1 plus sine theta. And so since these are exact quantities, you can cancel those, and so you're left with 1 over cosine theta, and that's going to be secant theta. This next problem has a lot of tangent in it, and notice really these tangents are common factors, and so for this one we can do a little bit different. We can factor out tangent squared and have 1 minus sine squared y, and then we know tangent squared, that's going to be sine squared y over cosine squared y, times, and here 1 minus sine squared is cosine squared y, and we can put that over 1 as needed and cancel your cosines, and so this one is going to be sine squared y. All right, moving on to number 12. Very similar here, you do have a common factor, so I'm going to factor out that sine cubed x. So we have sine cubed x, and that's going to leave us with cosecant squared x minus 1, and this is all over cosine cubed x. Okay, and on the inside of this, notice we might have an identity here, a Pythagorean identity. We know that cotangent squared x plus 1 equals cosecant squared x. So if we subtract that 1 over, then we're left with cotangent squared. And so that's going to be what we can replace inside the parentheses. So I have sine cubed x times cotangent squared x over cosine cubed x. Now, over here, this cosine cubed, sine cubed over cosine cubed, we can put that together since we're multiplying in the numerator, and that's really going to be tangent cubed x times cotangent squared x. And really a good way to think about this, we could break this apart or do the reciprocal right here. Either way, let's go ahead and flip that. So that's really going to be tangent cubed x times 1 over tangent squared x. And here we see if we put tangent cubed over 1, these are going to cancel, leaving just a tangent x. And now we're going to move on and look at our homework. And again, for the first problem, we are simplifying this down as far as we possibly can go. So for this first one, we have sine squared over tangent squared. So that might be a part right down here that we need to do some rewriting. So we're going to have 1 minus sine squared x over, and then tangent squared is going to be sine squared x over cosine squared x. And so right here we need to work on that fraction. So again, we have 1 minus, we're going to have sine squared x times the reciprocal here. So that's going to be cosine squared x over sine squared x. And those sine squareds are going to cancel. So I have 1 minus cosine squared, which leaves us with sine squared x. Okay, so for number 2, again, a couple of things rewriting. We see that cosecant here, that is the reciprocal of sine, or we can even flip sine over, either way. Let's try cosecant. We know that's 1 over sine of A over sine of A minus, and let's see, cotangent is 1 over tangent A over tangent A. And so let's simplify each one of those. That's going to be 1 over sine of A times 1 over sine of A. So that's 1 over sine squared A minus, and this is going to be 1 over tangent squared A. And we can flip that over. That's cosecant squared A minus cotangent squared A. And that's just our Pythagorean identity rearranged, and that's going to give us 1. Okay, for our next problem, here it looks like we have a GCF of 3 in each term. So let's factor out that 3. And we're going to have 1 minus cosine squared theta over sine theta. And again, our Pythagorean identity tells us 1 minus cosine squared is sine squared theta over sine theta. And one of those signs will cancel. So that's just going to leave us with 3 sine theta. Okay, for number 4, we will need to go through and change this denominator. This is one of those Pythagorean identities, and that is going to be equal to tangent squared alpha. So we really have secant squared alpha over tangent squared alpha. And rewriting that, we see we have 1 over cosine squared alpha, and tangent squared is going to be sine squared alpha over cosine squared alpha. And here we can rewrite those fractions. So we have our top fraction times the reciprocal of the denominator. And notice that your cosine alphas will cancel. And so we have 1 over sine squared, which is cosecant squared alpha. Okay, with number 5, it looks like we might have a GCF here. So we can factor out sine u in the numerator. So let's see what that's going to give us. We're going to have sine u times cosine squared u plus sine squared u. And that's going to be over sine squared u. And then that numerator here, that is a Pythagorean identity. All of that is equal to 1. And sine u times 1 is just sine u over sine squared u. And that's going to be 1 over sine u, which is going to just be cosecant u. Okay, for our next problem, this one, it looks like we're going to have to do some foiling here just because of all the different terms and parentheses. So if we start multiplying this out, that's going to give us tangent squared beta. And then out here is going to be minus tangent beta, secant beta. Inside here, plus secant beta, tangent beta. And then our last one is going to be minus secant squared beta. So, and all of this, oh my gracious, is over secant beta. Now, something that will help here, notice that these terms are the same with different signs, so those are going to cancel. And so I have tangent squared beta minus secant squared beta over secant beta. Now, tangent beta minus secant squared beta, that is one of our Pythagorean identities, and that's going to be equal to -1 over secant beta. And so that's going to give us negative cosine beta. Okay, this problem looks like it's going to be a mess. Let's go through and put everything in terms of sine and cosine. That might be one of the better approaches here. So I know tangent is going to be sine of A over cosine of A. Secant is 1 over cosine A minus cosine A. And all of this is over sine of A. Okay, now let's go ahead and do our distributive property in the numerator. And so that's going to give us sine of A over cosine squared A minus, and notice that cosine over in the second part is in the numerator, so it will cancel with the other, leaving us just sine of A. And all of that is over sine of A. Now with this, we can even flip over from the denominator if we want to and distribute through by 1 over sine of A. That might simplify this even a little more. So let's see what we have here. That over sine A is the same thing as 1 over sine of A times sine A over cosine squared A minus sine of A. And we're going to put that sine A over 1. And when we distribute this, notice that we end up with 1 over cosine squared A minus, and over here we're going to have 1. So this ends up being secant squared A minus 1, which is going to be one of our Pythagorean identities. And this simplifies down to be tangent squared A. So that one worked out to be pretty neat. Okay, moving on to our next problem. Notice we are multiplying in the numerator, so that's going to kind of throw a wrench in things. It might be a good idea on this one to go over to sine and cosine again. So in the numerator, that's 1 over sine theta times cosine theta, and I'm going to put that over 1. And all of that's over tangent theta is going to be sine theta over cosine theta plus cosine theta over sine theta. Okay, so we have a couple of different parts here. In the numerator, that is multiplication, so I'm just going to put that together and have cosine theta over sine theta. And then all of that's over, and then in the denominator, we're back to needing to do some cross multiplying here. So that is going to give us sine squared theta plus cosine squared theta, and that's all over cosine theta times sine theta. All right, so let's see what that gives us. In the numerator, that's not changing a whole lot just yet. In the denominator, though, that's going to be 1 over cosine theta times sine theta. And now we can go through and divide those fractions. So we have, again, cosine theta over sine theta times our reciprocal, so that's going to be cosine theta over, times sine theta, all over 1. And notice those sines will cancel. So it looks like all of this, we're left with cosine squared theta. Okay, for number 9, this looks like another candidate for going through and changing everything over to sine and cosine. Now, for this one, our numerator is already sine, so I'm going to have sine squared alpha over sine squared alpha over cosine squared alpha plus tangent squared, but we're changing that, to sine squared alpha over cosine squared alpha. And all of that is over 1 over cosine squared alpha. All right, so let's see. From here, we can simplify. We are going to multiply by this reciprocal. So we're going to have sine squared alpha times, we'll put that over 1 times cosine squared alpha over sine squared alpha. Plus, in the same situation over here, we're going to take that numerator and we're going to multiply it by the reciprocal. So that's going to give me cosine squared alpha over 1. So it looks like a lot of these things are going to simplify out. So the first term is going to be cosine squared alpha plus, and notice the second one is going to be sine squared alpha, and all of that's equal to 1. So that worked out nice. Now for number 10, and again, great candidate for doing everything over in terms of sine and cosine again. So here, cotangent, we know that is cosine x over sine x minus cosecant squared, I know that's 1 over sine squared, times, and then tangent is sine x over cosine x. So it looks like we might get some stuff here to cancel. We do have here cosine x over sine x minus, and one of these is going to cancel, so I'm left with 1 over sine x times cosine x. And so from there, it looks like we can do our cross multiplying as usual to get our denominators and get all of this added or subtracted. So if we cross multiply here, we're going to have sine x times cosine squared x minus, and here that's going to give us sine x. And this is all over, and I wouldn't multiply this out so much as just rewrite it here. Sine x cosine x, because I'm hoping some stuff will cancel. Notice in the numerator we have another GCF of sine x. So I'm going to factor out sine x, and we're going to have cosine squared x minus 1 left in the numerator. In the denominator we have sine x times cosine x. Now this portion here is that Pythagorean identity rearranged. And I believe that's probably going to give us a negative sine squared. So let's write out what we have. We have sine x, that's going to be this one, times negative sine x, sine squared x. And then in the denominator we have sine x times cosine x. So let's see, we can cancel some things here. And so it looks like we're going to have a negative sine x over cosine x. So that's going to leave us a negative tangent x. Okay, for this one, it looks like, again, we're going to have to find a common denominator and put these fractions together, which is going to end up as cross multiplying here. So I have 1 plus sine y times 1 plus sine y plus, and then over here cosine squared y. And in the denominator, I'm not going to multiply any of that out if I can help it. So I'm just going to do some rewriting here. In the numerator, we are going to have to FOIL all of that mess out. So when we do so, we're going to have 1 plus sine y plus sine y plus sine squared y. And then we have plus cosine squared y. So that's going to be handy. And of course, every bit of that is over cosine y times 1 plus sine y. Now, we see that this portion right here, that's an identity. All of that is 1. So, let's see, we're going to have 1 plus sine y plus sine y plus 1 all over cosine y times 1 plus sine y. Now be careful about wanting to cancel that 1 plus sine y. Those are not the same thing just yet. We're going to have to combine the numerator and factor out that GCF. So here we're going to have in the numerator 2 plus 2 sine y over cosine y times 1 plus sine y. Now before we get all antsy and want to do some canceling, you've got a GCF here of 2. So we're going to factor out that 2. And we are going to have 1 plus sine y left. Now we can go through and do the canceling that we want to do. That's cosine y times 1 plus sine y. Now we're allowed to cancel those. And we have 2 over cosine y, which is just going to be 2 secant y. Okay, for our final homework problem, it looks like we're going to have to do some rewriting in the numerator. And so, let's see, we have cosine beta times, and tangent squared, so that's going to be sine squared beta over cosine squared beta. And then all of that's over 1 plus cosine beta. And so we see in the numerator that one of those cosines will cancel. So we have sine beta, sine squared beta, over cosine beta. And then all of that's over 1 plus cosine beta. So everything looks like it's trending toward cosine beta, but then we've got this strange sine beta, sine squared. But if we go back and we remember that sine squared, let's go back up here, sine squared beta plus cosine squared beta is 1. And really, we can move over that cosine, so we do have a way to transform sine squared into 1 minus cosine squared beta. And that might be the substitution we need to make with this one. So when we make that substitution, and I'm going to take that cosine squared, and I'm going to put that down here in place of sine squared. And so that's going to give us something that is all in terms of cosine. So here we're going to have 1 minus cosine squared beta, and that's going to be over cosine beta. And then I'm going to go ahead and multiply by the reciprocal, so 1 over 1 plus cosine beta. Now for this part here, the top, we need to factor this. And this is the first problem that we've seen where we might have to factor. And so this would factor into 1 minus cosine beta times 1 plus cosine beta. And then all of that's over cosine beta. And then times 1 over 1 plus cosine beta. And now we're to the point, since we have a factoring problem, we've got that out of the way. Now we can go through and cancel. We should be able to cancel this term with this term up here. So that's going to help. And now we can put all of that together over the denominator. And so we're going to have 1 minus cosine beta over cosine beta, and we can decompose that fraction, and we have 1 over cosine beta minus cosine beta over cosine beta. And so we're going to have secant beta minus 1. And this one is going to be as far as we can get it. Normally we have a single term, but for this one, that's one of those exceptions.